Okay. Good morning, one and all. Today we will discuss about web security considerations, secure socket layer and transport layer security, and third one, secure electronic transaction. Uh, Nowadays, web security plays a vital role because usually the communication is happening between client to server or different types of nodes, and it is a communication between peers and so on. Usually, it is used by business, government, individuals, but internet and web are vulnerable. Means earlier also we have discussed about internet means it is like public transport, like public communication. Means when the client sends any mail to the server, automatically the mail should be passing through different types of routers. Routers means like those are like public, means anyone hack that particular router. And similarly, means web and router are vulnerable. And we have a variety of threats: integrity, confidentiality, denial of service, and authentication. Means we know very well what is integrity? Integrity means when the sender sends the data, the receiver may receive the data. But here the question is the receiver receives the exact data sent by the sender. So that is the question mark. Here, how to check whether the received data is equal to the sender's data or not, or if it is original one or modified one or altered one, whatever it means. So that is we can prove the integrity through different types of mechanisms. First one is MAC, second one is hashing. Okay. So in the case of MAC, definitely there is a need to provide one shared secret key between the sender and receiver. Means after generating some MAC, uh, the receiver will receive two components. First one is original message. Second one is MAC given by the sender. So in such scenario, the receiver will calculate the same MAC once again from the received message, and he will check whether the received MAC and calculated MAC, if both are same, then definitely the received message is original message which was given by the sender. If both are different, automatically it concludes it is altered by somebody. Somebody means hacker or some other whatever it may be. That is altered one. When it is an altered one, automatically the receiver will discard that particular message. That is about integrity. Second one is confidentiality. Usually, uh, when the data is under communication, we can suspect like many hackers they are trying to hack the data. So when after hacking, when data is in plain text, automatically the hacker can read the data and understand the meaning of the data. But when the data is encrypted with the help of symmetric key cryptography or asymmetric key cryptography, in such scenario, so we can consider it some confidentiality is there, because after the hacker hacks the data, the hacker cannot understand because it is not in a readable format. So when it is not in a readable format, automatically some security is there for our data. Means hacking may be easy task, but decrypting the data is not a easy task. So at least we can provide some security through confidentiality. Next one, denial of service. Means when we talk about the client and server communication, in the scenario, Always the hackers they are trying to create some problem in server side. Means the client should suffer from getting the service from the server. Means automatically it creates some bad impression on the company, because always the server is looking like busy. Automatically we are feeling like, means as a client we are feeling like the server is always busy. Their maintenance or their coding is not up to mark, and the service is not up to mark. So automatically it creates bad impression in client side. So to create such things, miss the hackers always miss unnecessary. Always they are trying to send some unnecessary messages to the server, unnecessary request to the server. Means actually just assume the server capacity is 100 requests per second. But always the hackers they are trying to send 200 messages, 300 requests at a time. So it creates some overload on the server side. So when it is overload, automatically the server will not give any service to the legitimate clients or legitimate users. Okay, that situation is called denial of service. And the next one, authentication. So here, authentication, when there is a communication between the client and server, or communication between customer and merchant. So in such scenario, those two are unknown, unknown persons or unknown users, whatever it means. So here, definitely the client prove himself is a legitimate user to the server and vice versa. So for doing all these things, the authentication plays a vital role. Means server should know about the client, and the client should know about the server, and they should believe the server is a legitimate legitimate user, and client also legitimate user. Then only they can start the communication. Okay, and need added security mechanisms. Definitely, some security mechanisms are required. So here, security protocol stack. Already you have observed in the compute network subject, means TCP/IP protocol stack, and second one ISO OSI layers. So among them, the first one, network layer. When we talk about network layer, this is the picture: HTTP, FTP, SMTP, TCP, IP by IP security. Okay, and here we can take security at IP, that is IP security. When we talk about transport layer, transport level, that is HTTP, FTP, SMTP, and SSL by TSL, TCP, IP. Okay, so here this is the place of SSL and SSLR, TSL, and at application layer. We can take care about security at through Kerberos, SMIME, PGP, SET, secure electronic transaction. Okay, these are the three different possibilities for taking security. First, we will discuss about secure socket layer. Here, actually, the place of SSL in between application layer and transport layer. Here, originally developed by the Netscape and version 3. Actually, it started with version 1, then version 2, now version 3. Not now. In olden days, it was version 3. After version 3, it was stopped. This SSL is stopped at version 3. Next one, subsequently became internet standard known as a TLS, Transport Layer Security. And now, in place of SSL, new standard has come, that is TLS, Transport Layer Security. It uses TCP to provide a reliable end-to-end service. Just you know very well, what is TCP and what is UDP, and what are the differences and what are the advantages in TCP. So in the case of TCP, it is like it provides reliable communication. Means reliability is 100%, and all the packets in the receiver side will be in means proper order, means sorted order. Uh, and each and every packet will reach the destination without any problem. So that is the reason both SSL and TLS both uses TCP only. SSL has two layers of protocols. Okay, this is SSL architecture. Just a minute. Okay, this is SSL handshake protocol, SSL change cyberspec protocol, SSL alert protocol, yes, HTTP, that is old one only, nothing is new. Then SSL record protocol, then existing are TCP and IP. So this is the overall architecture of SSL. Means top layer and second layer belongs to SSL architecture. Now, before going to discuss about SSL architecture, first of all, there is a need to discuss about SSL connection and SSL session. Here, SSL connection, a transient peer-to-peer communication link. Okay, it is like peer-to-peer communication link, and it is associated with one SSL session. Means one session belongs to connection, and a connection is linked with session. Here, suppose when there is a need of communication between client and server, first of all, there is a need of connection between the client and server. It could be wired connection or wireless connection. First of all, connection should be established between the client and server. Okay. After that, there is a need of session. Okay. Yes, many times we have discussed about SSL session. Session is must for communication. This connection is that is basic. That is base. After connection, definitely session is required. Session means like that is validity of the connection. Means during that validity, they can communicate each other, the client and server. So, an association between the client and server created by the handshake protocol define a set of cryptographic parameters and may be shared by multiple SSL connections. Okay, so these are different points related to a session. So when session is expired, automatically the communication will be stopped between those two systems, client and server, or two different systems, whatever. So here SSL message integrity. Earlier also I have given some points. Message integrity means that is possible through MAC. So here in SSL record protocol, it implements integrity with the help of MAC. This is similar to HMAC but with different padding. That's it. Everything is same to HMAC. Second one is confidential. How to provide confidentiality? Using symmetric encryption with a shared secret key defined by the handshake protocol, that is AES, IDEA, RC2, DES40, DES, 3DES, Forteja, RC440, RC4, 128 bit. So these are different algorithms which are related to symmetric encryption, and they can use any algorithm. And the message is compressed before encryption. This is very important point. Message is compressed before encryption. Okay, and this is the picture. Already I told SSL is in between the application layer and the presentation layer. And here, when application data is ready, the application data is divided into different fragments like blocks, different blocks. Okay. After that, the each fragment will be compressed according to the compression algorithm, which is agreed by both client and server. Automatically, the fragment means the compressed fragment size will be decreased. After that, there is a need of calculating MAC, and when MAC is ready, that MAC is appended to the compressed fragment. Now again, it became like the size of the fragment only. Means actually the plain text fragment and compressed fragment and MAC, the size both are same. Okay. After that, the entire component will be encrypted with the help of the symmetric key cryptography algorithms. Any algorithm, maybe DES or 3DES or AES, IDEA, RC4, and okay, these algorithms, they can take any algorithm. After that, append SSL record header. Okay, and for each fragment, there is a need to add the SSL record header. Okay, now we will check what is a record header. Now SSL record format, and these are the components: content type, major version, minor version, compression length, plain text, optionally compressed, MAC. Okay, so here the entire thing will be encrypted. Now what about content type? Okay, uh, it has a content type. Next one, major version, minor version. Suppose there is a version 3.2. 3.2 means 3 is a major version and 2 is a minor version. Next one, compressor length. Compressor length means already you have observed in previous slide. When there is a fragment, the fragment will be compressed. So like that, the entire application data is compressed. Now, the compressor length means after compression, the length of the length of that fragment. Okay. Next one, plain text. Plain text means the fragment contains some plain text. That is the plain text. Next one, MAC. After calculation of MAC, the MAC will be added, but the entire thing will be encrypted with the help of symmetric key cryptography algorithms. Now, the SSL record protocol. Already you have observed one of the component is change cyberspec protocol. Here, change cyberspec protocol, that is like what that before processing it is 0, and after processing it is 1. Means fragmented. Means different fragments are there. Those fragments will be processed before processing it is 0, after processing it is like 1. Next, one more means field, that is alert protocol. We will discuss alert protocol. Next, one third one is handshake protocol. Here, type is 1 byte, length is 3 bytes, and content that is 0 byte. Next one, fourth one, fourth one, uh, upper layer protocols, that is HTTP. Now, change cyberspec protocol. That is one of the three SSL specific protocols which use SSL record protocol. That is a single message causes pending state to become current state, hence updating the cyber suit in use. Okay, that is like means is it pending state or pending state means is completed like that. Okay. Next one, SSL alert protocol. So here, total 2 bytes are there. One byte for whether it is warning message or fatal error. Then second one is specific alert message. Suppose a fatal error, unexpected message, bad record MAC, decompression failure, handshake failure, illegal parameter. Those things comes under fatal error. Second one, warning. Close notify, no certificate, bad certificate, unsupported certificate, certificate revoked, certificate expired, certificate unknown. Okay, these are two different messages are there. First one is warning message. Second one is fatal error message. Then compressed and encrypted like all SSL data. This is handshake protocol, and one of the component is handshake protocol. That is like it allows server and client to authenticate each other, to negotiate encryption and encryption algorithms and MAC algorithms, and to negotiate cryptographic keys to be used. Next one comprises a series of messages in phases. Means usually the handshake protocol means it contains four phases only. Here it is. Phase one is establish security capabilities. Second phase is server authentication and key exchange. And third one is client authentication and key exchange. And fourth one is finish. Okay, these are different pages in handshake protocol. Just a minute. Okay. This is SSL handshake protocol. Just all of you check it. The client server model, and here phase 1, phase 2, phase 3, phase 4 are available. In phase 1, first of all, the communication is initiated by the client only. The client sends one hello message. It establishes security capabilities, including what is the protocol version, what is session ID, cipher suit, compression method, and initial random numbers that is given by the client. And in reply message, the client server also sends a hello message, and after that, the phase 2 will be started. In phase 2, the server may send class certificate. If certificate is not available with the server, then automatically it starts the key exchange. Next one, server requests the certificate from the client, and the server signals end of hello message phase. Okay, that is like it says hello done. Okay, that is the message. That is the message given to the client. Now phase 3 will be started. In phase 3, the client sends certificate. Means certificate means its own certificate. If a client don't have that digital certificate, automatically it is going to exchange the keys between the client and server. Then certificate verified and already given by the server one certificate. That server will be verified by the client. That is the message. Certificate verify. Then page 4 will be started. Change cipher spec. Means when the what is that message exchange between the client and server is completed, automatically change cyberspec. That value will be changed to 1. Initially it is 0, now it is 1. Next finished. Similarly, in page 4, the server also sends a change cyberspec, then it sends finished message. So this is the overall picture of the client server communication. That is like the communication will be started based on this SSL handshake protocol only. Okay, just once again, here four pages are there. Phase one, that is like the client and server show their capabilities and agrees on some specific values only. Okay, that is phase one. In phase two, the server authentication will be initiated, and the server digital certificate will be given to the client, and it will ask sends client certificate to the server. Okay, in phase 3 it sends its own certificate to the server. If everything is okay, means both will be verified by client and server, then the SSL handshake messages will be completed. Next, TSL. Already, already I told. Uh, TSL is an advanced version of SSL. Actually, SSL 1, SSL 2, SSL 3 came to technical world, but after that, it is replaced by TLS, Transport Layer Security. And what are the major differences between these two? First one, in record format version number, uses its Mac for Mac. Actually, in SSL it is Mac, but in TLS it is HMAC. Next, third one, a pseudo random function expands secrets. A pseudo random number function expands secrets. Next, has additional alert codes. These alert codes already you have observed when there is a some wrong thing is happening, and it tells whether it is a warning or fatal error. So in such scenario, it gives some alert messages along with alert codes. Okay. Then some changes in supported ciphers, changes in certificate types and negotiations, and changes in crypto computations and padding. Okay. Till today, we have discussed about the SSL and SET. Okay. Now we will discuss about SET, Secure Electronic Transactions. Okay. So here, it is related to encryption and security specifications, and to protect internet credit card transactions, developed in 1996 by Mastercard and Visa. It is first of all, it is not a payment system, rather a set of security protocols and formats, security communications among parties, trust from use of X.509 V3 certificates, and privacy by restricted info to those who needs it. This is the overall picture of a set component. Card holder. Okay, suppose different types of users are there, different types of customers are there in online shopping. So when he wants to purchase something, definitely first of all he should prepare the order list. Means what type of items he wants to purchase. That is nothing but an order list. Then this request should pass through internet, and finally it reaches the merchant. Okay. So after that, the merchant means checks the payment information. Really, the user has funds or not. If user has funds, then only the orders will be released by the merchant. After that, a normal component is there, that is a certificate authority, which earlier also we have discussed about certificate authority. When the client, when the sender and receiver both are known persons, then definitely there is no use of any certification authority or digital certificate. But when both are unknown persons, like here, the user and merchant both are unknown persons, how can we have some interaction between us and Flipkart or Amazon? So it is not at all possible because both are unknown persons only. So in such scenario, definitely certificate authority plays a vital role, and digital certificates are necessary. So here digital certificates and issuers will be there, and those issuers are nothing but the Mastercard and Visa. The central process is initiated by Mastercard, Visa, and some other card issuers only. Okay, but whenever there is a need, acquirers will come into picture, and the acquirer, then payment gateway will be connected. This is overall picture of set components. Now set transaction. So how the transaction will be going on? First one, customer opens the account. Customer receives a certificate. Then merchants have their own certificates. Customer places an order. Merchant is verified. Order and payment are sent. Merchant requests payment authorization, and merchant confirms the order. Merchant provides goods or services. Okay. Now dual signature. Here, dual signature plays a vital role. And what is a dual signature? The customer creates dual messages. First one is order information for merchant and payment information for bank. Here, neither party needs details of others because the customer means the merchant don't know about payment, and bank don't know about the order details. Okay, both are should be like independent, but must know they are linked. Means there should be a link between the merchant and the bank because merchant requests for payment, and bank gives reply or gives the amount to the merchant. Okay, and use a digital signature for this. Signed concatenated hashes of OA and PA. So here digital signature is equal to encryption with private key of the customer, and the components are hash of PI and hash of OI and whole hash of whole thing. Set purchase request. So here, set purchase request exchange consists of four messages. First one is initiate request, get certificates, initiate response, signed response, and purchase request of OA and PA, and purchase request acknowledgement order. This is the purchase request by the customer. The left side you can check means payment information plus a dual signature plus OIMD means OIMD means order information message digest. Okay, then the whole thing will be encrypted by the shared secret key uh, of the what is that server. Okay, then it is encrypted by that is the shared secret key between the customer and the bank. Okay, KS. Then it is encrypted by public key of the bank. Okay, that is digital envelope. The previous one, that is encryption of the left part, that is first part. Second component is digital envelope, and the third component is miss PIMD, miss payment information message digest. Next one, order information, that is in plain text only. Next again, your signature. Next, card holder certificate. Okay, card holder certificate. Then the entire thing will be received by the merchant, and some part of the received message will be given to the payment gateway. Okay, that is component 1 and component 2 will be passed to the payment gateway. So here PI is payment information, OI is order information, PIMD PI message digest, OEMD, order information message digest, and E is nothing but encryption. RSA for asymmetric, DS for symmetric, KS is temporary symmetric key. Okay. Next PUB, bank's public key exchange. Next one, purchase request merchant. Verifies cardholder certificate using certification authority signs and verifies dual signature using customer's public signature key to ensure order has not been tampered with in transit and that it was signed using cardholder's private signature key. Next third one, process order and forwards the payment information to the payment gateway for authorization. Okay. Next, sends a purchase response to the cardholder. And this is a purchase request by Miss Merchant side. Actually, this entire information will be received by the merchant, and the merchant should check whether the order information is perfect one or altered one. So, for this one, integrity plays a vital role. So here, merchant received PIMD and order information in the plain text. Then it calculates hash function. Then it generates one OAMD, then concatenates PMD and OMD, then applies hash function, then it gives POMD, and from digital signature, from cardholder certificate, it gets means public key of the customer, then the digital signature will be decrypted and it gives POMD and calculated POMD and the received POMD if both are same or not. If both are same, then only the merchant will accept the order information. Okay, otherwise it simply discards the order information. Then payment authorization. Purchase related information PA plus dual signature plus OAMD plus digital envelope. Authorization related information authorization block, transaction ID and PR merchant means private key of the merchant and digital envelope here temporary key KS that is means encrypted by what is it PUG that is overall encrypted and certificates cardholders CA merchant CA and merchants T exchange CA and payment gateway authorization verifies all certificates, decrypts digital envelope of authorization block to obtain symmetric key and then decrypts authorization block and verifies merchant signature on authorization block and decrypts digital envelope of payment block to obtain symmetric key and then decrypts payment block and verifies digital signature on payment block and verifies that transaction ID received from merchant matches that PA received from the customer and request and receive an authorization from the issuer and sends authorization response back to the merchant. Okay, this is payment capture. Okay, here merchant sends payment gateway a payment capture request. Then gateway checks the request that causes funds to be transferred to merchant account and notifies merchant using capture response. Next summary. Needs for web security and SSL TLS transport layer security protocols set secure credit card payment protocols. Okay, this is end of the section.